Now we have to find the equation which is equidistant from the points minus 1, 3 and 3, 5. Now there are two approaches to this. The first approach is using the distance formula. So we have the 2 points PQ and the point that we need to find is equidistant. So we can use the distance formula, x minus minus 1 whole squared plus y minus 3 squared should be equal to square root of x minus 3 squared plus y minus 5 squared, and you can simplify this and you can get the answer. I want to tell a different approach in which we will use some geometric property. So if you look at the points PQ, the point that we need to find x comma y is equidistant. So let's say this is the point x comma y and these are the two distances. Now since this is equidistant, so this is sort of forming an isosceles triangle. Now to find the equation, we basically need to find the trajectory of this point. So when I change this, again it forms an isosceles triangle. And you can see that to be equidistant, this has to be on a very special line. And this line is basically the perpendicular bisector of PQ. Okay, and this is the midpoint. This point is also equidistant from the two. So all we need to find is to find the equation of the perpendicular bisector, and that is very straightforward because we know the segment PQ. The slope of segment PQ will be 5 minus 3 upon 3 minus minus 1, y2 minus y1 upon x2 minus x1. So this comes out as 1 by 2. Now to find the slope of the perpendicular line, we know that m1 m2 is equal to minus 1. So m2 is minus 1 upon half is equal to minus 2. And to find the equation, we can find the midpoint. The midpoint of PQ will be equal to minus 1 plus 3 by 2, x1 plus x2 by 2 and y1 plus y2 by 2. This is 1 comma 4. So what will be the equation? It will be y2 minus y1. So we can take 4 equal to slope m times x2 minus x1. This becomes y2 minus 4 is equal to minus 2x2 plus 2. y2 is equal to minus 2x2 plus 6, or we can say y plus 2x equal to 6.